Sorry, you caught me while I was listening to some music. Give me a sec. I'll be right back and we'll get this lesson. All right. Sorry, I was just getting really pumped up for today's lesson on what is an inverse, all right? And hopefully you remember talking about this back in the day during AAA or whatever class you took freshman year for algebra 2, second year algebra. Anyway, let's just dive into this, okay? So let's see if we can remember this. Inverses of functions. Okay, so inverse is the key right here. We're going to take things and we're going to invert them, all right? So first off, this whole unit we've been talking about functions. Okay, that's really what this whole unit is about. How mathematical operations work and how we put them into, equations that works. Typically being a function of f of x or the y variable, right? And usually how we do that is we map them one-to-one. We map from one x value to one y value, right? Input to output, okay? So as you hopefully know at this point, these points are plotted on the xy coordinate plane as x then y, or it might be helpful sometimes to talk about them as x and f of x. It kind of depends on whether you're actually graphing or whether you're talking about the functions in terms of how well they're working or what their inputs and outputs are. So, how do we find the inverse of a function? Well, if we were to take these values and switch their order, we would have the function's inverse. And that notation is denoted by this, f with the little -1 of x, standing for the inverse of f of x. So once we put this little bitty -1 symbol up here, now we are talking about the inverse of the original function we were talking about. Okay, so how do we do this? Well, really, there are two key steps, okay? The first thing you want to do, that's an actual thing you do, is you want to switch, there's that word again, x and y. Okay, now if you don't see y in there, that's because maybe you kind of feel there's like a step 0, which is you need to rewrite f of x as y, or whatever the notation is. So if it makes it a little easier for you, I'm going to rewrite this example problem as y equals 5 minus 3x divided by 2. Okay, and so when I go to switch, there's that word, switch. I'm going to switch the letter y and the letter x, and that's it. And maybe I'm going to add one word, only. Okay, you're not moving anything else. So even though there's a 3 in front of this x, I'm not going to move the 3. All I'm going to do is I'm going to change it so it says x equals 5 minus 3 y divided by 2. Okay, so I just switched where the letters were. And then step number 2 is you are going to isolate. Some people might say solve. Maybe that word might be more familiar. For y. Okay, so we are going to get y all by its lonesome. So how am I going to do that? Well, I'm going to start as far away from y as possible. So the first thing I'm going to do is I'm going to multiply by 2, because that's going to get rid of this denominator. So I'm going to multiply by 2 on the left side. So I'm going to have 2x equals 5 minus 3y. Okay, and then I'm just going to keep working from farthest away from y to closest. So the next thing I'm going to do is subtract this 5, since this is technically a positive 5. So that'll eliminate it on the right-hand side, and it'll move it over to the left-hand side. And then last but not least, I am going to undo the fact that there is a -3 right here next to this y. And so I'm going to divide by -3. And so then what I'm going to end up with is, and if you want to call this our third step, you're going to rewrite the inverse as f inverse of x. So what is the final thing we get here? Well, instead of, y equals something, we're going to have f inverse of x equals the fraction 2x minus 5 over negative 3. Now, there are a couple of things I want you to notice about this equation that I haven't formally mentioned about the idea of inverse, okay? So, a little side note. Inverse. All operations. And if you've forgotten what operations are, turn your brain on. Mr. Covey says that all the time. Turn your brain on. Have an inverse. So, what are operations? Well, like addition. Okay, and what do we normally say with addition? We say subtraction. What about multiplication? We usually say division. At least we usually say those together. Why do we connect them in our brains? Why do we say them together? Because they are inverses of one another. So to check your work, I want you to look at your new function. See how it has 2 times x multiplied? In the original function, you should have the inverse. So if you have multiplication in your answer here, then back in the original, we should be dividing by 2, which is exactly what's happening in this fraction. And here we have subtracting 5. And in the original function, I know it doesn't look like it, but technically that's a plus 5. You are adding 5, all right? And then you're dividing by negative 3 in this answer. And in the original, you are multiplying, right? That's multiplication. You're multiplying by negative 3. So all the operations in this new equation are the inverse of the original. So that's how you know that you have, in fact, found the inverse. And the key thing is this first step, which is that you switched x and y. So if you were wondering what song I was listening to when you guys caught me, here getting ready for this lesson, I'll show you.
Yo, where you at? Yeah, I'm already down here. All right, you ready? Come on, man, that's what I do. Yo, mic check, mic check. Yeah, here you go. Oh, no, he over here. I heard you got that hot new thing. What's this called?
See, so even Will Smith knows the importance of switch those variables. All right, so with that, I would love it so much if you guys tried this second example right here, example number 2. So see if you can find the inverse of f of x equals 9 minus x squared, and remember to switch. All right, folks, welcome back. So hopefully you got to this point at the bottom where you found that the inverse was, at the very least, that you wrote square root of negative x plus 9. Now, heads up, when you're solving or isolating, right, like we were doing, and you take the square root, which, in case you didn't know, the square root is the inverse operation of squaring. They undo one another. Okay, so those are inverse operations. And so you should have a plus and a minus because you took the square root. And so when you take the square root, there's more than one answer. Okay, now there's some issues that come in to determining whether or not both of these functions, because the positive and the negative are 2 separate functions, can be the inverse of this original function. And we're going to kind of talk about that later. This video is really just about the process of finding an inverse. There is one other thing, though, that I want to relay to you in this video, which is about graphing. Okay, so, and this is a little prelude to what I'm talking about with the function you just found the inverse of. If you were to graph, so if you flip through, if you have your notes printed out and you flip through them a little bit, you should find these 2 graphs. And what you need to know is true about functions that are inverse is that they have this symmetry that we don't talk about too much, which is that they're symmetric along this line that's y equals x, okay? So if you drew a dotted line, diagonally along y equals x, there should be some symmetry in inverses. Now, if you notice this first pair right here, when you look at this dotted red curve, that's not a function, right? That breaks the vertical line test. So when you go to find an inverse, sometimes the function you write isn't actually a function because it breaks the vertical line test. And that's actually where that like plus and minus comes from. It comes from the fact that you've got the top of a curve and then the bottom of a curve. They're like two separate functions. Sorry, it doesn't like to make the highlighter curvy for some reason most of the time. So just kind of keep that in mind that sometimes when you find an inverse function, the equation you wrote might not also be a function. Just because the original is a function doesn't mean the inverse is going to be. However, over here, if you look, both of these equations along the dotted line, they pass the vertical line test, so they're good. So that's the last thing to keep in mind. And as I said, just remember, as you're finding an inverse, to keep in mind really these two middle steps. These are the key steps, switch and isolate, and you'll be good to go. All right. Peace out. Thanks so much for listening. Bye.